Unit 7, Lesson 4, Solve and Write Multiplication Equations. The essential question for this lesson: how can the division property of equality be used to solve multiplication problems? How many of you remember from a previous unit how to solve a proportion? There were two steps. In order to solve this proportion for the value of x, we were cross multiplying, so we would end up with 5x here, cross multiply here, and that equals 36. This is a multiplication equation. In step number 2, the opposite of multiplication is division, so we would divide. And x equals 36 divided by 5, which is 7.2. This takes us into our lesson for today. Before we start discussing or reviewing multiplication equations, I do want to discuss the vocabulary again. If you all remember, we are looking to figure out the opposite operations for the operations that you see in the equations. These are called inverse operations. When we solve an equation, we want to isolate the variable, and that means that we want to get it all by itself on one side of the equal sign. And whatever we do on one side of the equal sign, we do on the other in order to keep the equation balanced. In our unit on expressions, we learned that anytime there is a number in front of a variable, it is called a coefficient. And that coefficient multiplies that g. So multiplication is the operation that attaches the number and the variable. So what is the opposite of multiplication? Well, the opposite of multiplication and the operation we will use to get the variable by itself is division. So here are a few examples. The division property of equality says when you divide each side of an equation by the same non-zero number, the two sides remain equal. So we're looking for the value of p. Remember, our objective is to get the variable by itself. This is multiplication, so we're going to divide by 4. When we divide 4 by 4, we end up with 1. So as in our addition and subtraction equations, those 4's will cancel each other out, leaving us with p on one side of the equal sign. And p equals 6 because 24 divided by 4 is 6. And we can actually substitute that value into that equation to check it to see if it makes sense. So 4 times 6, which would be p, does equal 24. Example number 2. We want to get the z by itself, so we're going to divide by 16. And remember, you do that on both sides of the barrier, which is the equal sign. You want to divide by 16. These cancel, leaving you with z, and z equals 3. In the next set of questions, we would do the exact same thing. So we end up with 6x equals 36 is our equation. That equal sign is our separation. We're going to divide by 6 on both sides, leaving x by itself on one side of the variable. And 36 divided by 6 equals 6. In the next example, We're going to divide by 3 on both sides, leaving y by itself. And 42 divided by 3 equals 14. The third question, 14b equals 56. We're going to divide by 14 on both sides. And b is equal to 4. Okay, this next set of questions, I'd like you to try these on your own. Remember to do the substitution check. When you are finished, return to the video to check your answers. So in the first example, this is attached by to the x, the 5. Excuse me. So we want to divide by 5 on both sides of the equal sign. Remember that equal sign is our separation point. We want to make sure that we are performing the operations on both sides. 5 divided by 5 equals 1, so they will cancel. And x equals 25 divided by 5, which is 5. And we can check this by multiplying 5 times 5, substituting that 5 in for x. And 5 times 5 equals 25, so it does check out. In example number 2, the 8 is attached to the x, so we're going to divide by 8. These 8's cancel. 104 divided by 8. And that equals 13. Substitution check. 8, x is 13. 8 times 13 does equal 104. So that checks out. Now this one is a little bit different. It actually has 2 steps, which is why it's important to show your work on both sides. So in our last lesson, we learned that we get rid of addition by subtraction. So we're going to do that first. So remember, we're trying to isolate this variable by itself. So we are going to subtract 3 on both sides. These 3's cancel each other out, leaving us with 2w. And 2w equals 20, because 20 minus 3 is 23 minus 3, is 20. And now we can get the w by itself a little bit easier by dividing by 2, leaving w equaling 10. And to check our answer, we're going to substitute 2 times 10 plus 3 and see if this checks out. 2 times 10 is 20, and 20 plus 3 does equal 23, so it does check out. These multiple step equations, in order to solve them, you want to remove everything from the variable. Remember, we want to isolate that variable, and we always work backwards from order of operations because addition here is loosely attached to the w and the multiplication is closely attached, so we want to work backwards, which is why we subtract and then divide. You are going to have some practice problems to work on today. Please complete those problems on your additional practice and finish all of your work from the remainder of the lesson from yesterday.